Hi, Assalamualaikum and a very good day for my viewers. So today, we will present about the assignment of pressure in pipe. So before going any further, let me introduce of my group members of the fluid mechanic. First is me, Muhammad Amir Irfan bin Muhammad Shukri, nama matric B0920100491. Second is Muhsin Amili bin Noor, nama matric B0920102441. Third is Rushan anak lelaki Ranganathan, nama matric B0920105150. And lastly is Muhammad Aiman bin Razak, nama matric B09201013. So this is our content for the presentation. First is introduction. The introduction we explain about what is fluid mechanics, assignment brief, and material. Second is procedure. The procedure will explain about general setup, straight pipe, closed loop pipe, AC simulation, and computer aided design (CAD). Third is data and result. Data will explain the calculation and AC simulation result. Fourth, discussion. The discussion we explain about comparison between actual and simulation result. And lastly is fifth, conclusion. So, without any further ado, let me start with introduction. So, what is fluid mechanics? Fluid mechanics is the branch of physics concerned with the mechanics of fluid and the force on them. Examples of fluid are such as water, H2O, mercury, and air. The application of fluid mechanics. Area of application for fluid mechanics include in the field of mechanical engineering, civil engineering, chemical engineering, ship engineering, and etc. So this is our assignment brief. Pressure in pipe. Water pressure is described as the force or strength that is used to push water through pipe or other pathway and is created by altitude or height. In pipe, the pressure creates a pressure drop or pressure loss. So in this assignment task, we are able to investigate the flow in different configuration of pipe, such as the closed loop and straight loop configuration. Areas of application of this pipe configuration is the agriculture industry, where it is used in the fertigation of plants. So for the next slide, Aiman Razak will explain about the material. Thank you.
Hi, Assalamualaikum. My name is Muhammad Aiman bin Razak, and I will present about the material that we use to accomplish our assignment, procedures, and calculation from the result that we gain. So the material that we use was PVC hose clamp, T-joint, cutter, nipple hose, PVC glue, stopwatch, and measuring cup.
Hi, Assalamualaikum. A very good day, guys. Today, I will show you general setup for the assignment. First, we need this pipe for make several holes for straight line and closed loop line. First thing is, I will show you how to make hole in pipe. So, first we need this knife to make the hole. As you can see. So we finish cut the hole. So next step is we put this hose nipple into the pipe. To put the nipples pipe, we need hit the nipples pipe first. Once the nipples is heated, so we put this into the pipe. But be careful, the pipe is heated. Why we hit the nipples pipe is because we want to make a strong connection between pipe and nipples pipe. Okay, why we use this nipple pipe is we want to the water flow uniformly and the result is steady.
And then proceed to our procedures. So in our straight line water hose experiment, 5 holes were made on the PVC hose by using a cutter, and then we put nipple hose onto each hose and seal it with PVC glue to make sure there is no leaking. The distance between each hole was same, which is 5 meters. And then the PVC hose was connected with the pipe water, and hose clamp were used to make sure the connection was tight. And then the pipe water valve was fully open until maximum, and we measure the water flow rate of each hose by record the time taken for the water to fill the measuring cup up to 200 milliliter. And then onto our closed loop water hose experiment, we add another 5 more holes with the same distance to make it 10 holes on our PVC hose. The end of our PVC hose was cut and we connect it with T-joint connector to shape it into a loop. And after that, the hose was connected with the pipe water and the valve was fully opened until maximum. And the time taken for the water from each hose to fill the measurement cup to 200 ml was recorded.
Since Muhsin told me this now, okay, we are going to look at NC's 2022. Okay, we are going to use the fluid flow analysis. Which firstly we're going to look at the geometry. The geometry was designed using the design method.
Okay.
Can you guys see that?
Yeah, I can see.
Yes, yes.
Yeah, we can see it.
This is the geometry. This is exactly same like how we did the experiment.
Okay, this is for straight line.
Yeah, this is first line, which is a straight line. For the looping, I haven't completed yet. So once Aiman or Muhsin gives me the cat, then I can reset it to this.
Alright.
Okay.
Yep.
So next is the meshing. We'll do the meshing. Then once the meshing is set up, then once in setup, we'll run the analysis and then we'll post process the results. The analysis is solely done using NCs. Since I feel NCs is the easier software to be easy and complete software to do analysis than most softwares available.
Assalamualaikum to Ariza. My name is Muhsin Amili. Today I'm going to explain about the computer-aided design. The model is drawn based on real-life scenario after we conduct the experiment in real life. This drawing will help us to obtain the simulated data by using NC's analysis. There are two models that we draw using SolidWorks, consists of closed-loop model and straight model. So for the first model, I'm going to explain the straight model. Starting off by drawing the circle with 30mm diameter. Then we extrude the circle for 5000mm. Then we can see a PVC hose model completed. After that, we are going to draw the nozzle for this loop. For this straight model, we are using 5 nozzles. Before we are drawing the nozzle, we have to offset the top plane upward 8mm from its original position. Then we can draw 5 circles on the new top plane position. Each of the circles are spaced 980mm between each of them. To draft the nozzle, the circle diameter are 20mm. Then we can extrude all the circles to get a complete straight model. So for the closed loop, we are using the same procedure as the straight model, but the difference are the amount of nozzle we are using is 10, and the space between each nozzle is 490mm. At this point, we get exactly like a straight model. So how we get the closed loop model? We have to use command flex to bend the model up to 180 degrees. Then our closed loop model is complete. That's all for me. Thank you and Assalamualaikum.
Onto our calculation. For the pressure impact, we calculate the flow rate, the velocity and max pressure in the system. And for second part of the experiment, we calculate the flow rate and velocity for the straight pipe and closed loop configuration. So this is the measure and known data. So we measure the height of water faucet, the fluid density of water, the atmospheric pressure, diameter of pipe, radius of pipe, volume taken, and linear dimension or area. So this is how we calculate the flow rate in the system. We divide the volume with the time taken, and after we get the answer, we divide it with the linear dimension or area to get the velocity. And for our final answer, for velocity we get 0.275 meter per second. And then this is the formula that we use to calculate the max pressure, and the final answer that we get is 101.337 kilopascal. And then onto the calculation data for our straight pipe experiment. This is our final answer for each loop. And then this is calculation data for our closed loop pipe. And this is the flow rate and velocity for holes 1 until 10.
My name is Rushan. I'm from BMMH. Okay. Today, we're going to look at the ANSYS fluent analysis, which we have done for the assignment pressure and pipes. Okay. First, I would like to show you the meshing. For the straight pipe, we have 5 outlets and 1 inlet. Okay. So the inlets can be seen in the red, in the blue arrow, and the outlets can be seen in the red arrow. For the closed loop, there is around 10 outlets and 2 inlets. Because the reason why, because we have 2 inlets, is we have used a T in the actual experiment to send the fluid across the hole, across the pipe. Okay, the blue is seen as the inlet and the red is seen as the outlet. Okay, next we shall look at the total pressure from the calculation and also from the calculation in ANSYS. For the total pressure in the straight pipe, you can also see the contours where at the beginning the pressure is quite high, and along the system the pressure is not to say very low or not to say very high. It has a moderate pressure, and the minimum pressure in the straight pipe is around 101.306 PA, and when we convert it to kPa is around 101.306 kPa, and the maximum pressure is around 101.496 PA, which is also known as Pascal, and when you convert it to kPa, it's around 101.496 kilopascal. And for the closed loop, we are able to observe the contours where there is quite a very high amount of pressure along the pipe. For the minimum pressure, it's around 183.094 PA. Okay, and for the maximum pressure is around 101.375 PA. This can be also observed by seeing the contours, and you can also see it towards the right. Okay, next we'll look at the velocity for the straight pipe and also the closed loop pipe. Okay, the velocity for the straight pipe is around 0.545 meters second. Okay, and this can also be observed if it's quite large and everything. For each hose, each of the velocity can be observed. And for the closed loop, the velocity is around 0.275 meter per second. Okay, this can be seen when you zoom in into the model. For each hose, the velocity can be observed, and this can also be seen at the right hand side where there's a wide range in the contour lines. Okay, next we have also gotten the Reynolds number from the ANSYS fluent analysis. For the straight pipe, the Reynolds number ranges from 0.13 to 125.16. Okay, well, when we talk about Reynolds number, there is around 3, which is the laminar flow, transition, and also turbulent flow. Okay, for this analysis, we can assume that our pipe is running maybe below laminar or up to laminar flow. Okay, for the closed loop pipe, the range of Reynolds number is from 54 to 78.12, and this can be seen consistently in the system. When we see it consistently in the same system, we can assume that there's no pressure drop because it is constantly running in a loop and the pressure is constant in that. Okay, this can also be observed when you look at the contour lines where there is always consistent flow, and when you look at the Reynolds number, Reynolds contours, it shows that there's consistent flow around the system.
Assalamualaikum to semua. My name is Muhsin. Today I'm going to present about the discussion through the basis analysis and real life experiment. What we can get from discussion is what effect flow in pipes in general. First, we get the more we learn, the more water that's being forced through the pipe, the more pressure there will naturally be. Through any pipe size, higher water pressure will cause greater water flow. The pressure will decrease downstream, however, because of loss of friction and water velocity increases. So what happened to pressure in pipes? And in this experiment, we learned in water flow in pipe size and water pressure are dependent on each other, because if the diameter of pipe decreases, then the pressure in the pipeline will increase. As per Bernoulli theorem, pressure can be reduced when the area of conveyor is reduced. So the third thing we find in this experiment is what causes pressure loss in piping. A flow pattern and frictional pressure loss of two-phase fluids. Pressure loss is an inevitable occurrence in every piping system that happens due to friction, elevation changes, and turbulence caused by sudden changes in direction. So for the last discussion we get from this experiment is how does pressure drop affect flow rate? So I can explain is pressure drop and flow rate are dependent on one another. The higher the flow rate through a restriction, the greater the pressure drop. Conversely, the lower the flow rate, the lower the pressure drop. So that's all for me. Thank you and salam.
Thank you for listening and watching our presentation. Okay. Once again, my name is Rushan. I'm from BMMH. Okay. From this experiment, we are able to conclude that we were able to investigate the relationship between flow rate, velocity, and pressure. Other than that, what are the skills we learned along the way was we were able to create a model for computer analysis from the actual model by taking account certain measurements and also taking data from actual situations. We were able to identify the constraints involved in piping analysis, which were the pressure, the flow rate, and then the materials which are used in piping. And then we were able to investigate the effects of different configurations of piping on the velocity, pressure, and Reynolds number. When you say about different configurations, okay, the straight loop, in my understanding, the straight loop has a different flow rate than the closed loop, because when in the straight loop, it's a long line, and the longer the fluid travels, there are losses along the way. Although our length is not to say very long, it's around maybe around 2.5 like that, but there's still losses along the way. And when a system is closed, for example, the closed loop, it is closed in a way where the pressure is always constant and the flow rate, velocity is also constant. And when we are using it in fertigation, as the experiment suggested earlier on, okay, it is always advisable to minimize small aspects such as pressure loss and everything, because each plants, when you think about fertigation, each plants require equal amount of water. Okay, when there are losses like these, what will happen is not all plants will receive the same amount of water. And when we are applying this in real world applications such as fertigation of plants, or maybe in buildings for fire services, okay, it is always advisable to follow a closed loop where you get to minimize losses and also maintain flow rate, velocity, and pressure. Okay, we other than that, we were also able to post-process data using ANSYS Fluent for data acquisition. When I say about data acquisition, okay, we have already done a theoretical calculation, and the simulation data enables us to support our theoretical calculation. Okay, when we look at that way, we are able to compare between actual and also simulation results. And when it comes to designing, it is always best for us to simulate certain criteria and also certain situations before designing. And this is also very useful when you're designing a system and you're thinking the budget, you're having a budget constraint. This will enable us to cut budget and also design a more efficient system, since we already know where in the system there are drawbacks and also setbacks. Other than that, the most important thing is we were able to apply fluid mechanics theories such as Bernoulli's theorem, Reynolds number, flow rate formula to get the required data. And it is not only applied in this assignment, but this has also enabled us to study more fluid mechanics in detail and derive formulas which will be helpful for us to calculate fluid characteristics. Okay, and by doing this assignment, we have also it has also helped us in studying for our fluid mechanics course. Okay, thank you once again for watching our presentation. Okay, if you have any questions, please drop it in the comment box. Thank you.